The question is, find the value of alpha plus beta in the given figure. We look at two different solutions, one using trigonometry and the other one not using trigonometry. With trigonometry, it's actually quite straightforward because you know that tan alpha is 1 by 2 and tan beta is 1 by 3, and we know how to find the value of tan alpha plus beta. When you know the values of tan alpha and tan beta, you'll see that the value is 1, and so alpha plus beta must be pi by 4 or 45 degrees. However, a far more interesting solution is to not use trigonometry at all. So then, if you want to find the value of alpha plus beta, it's not going to help you much if these two angles are not next to each other, right? If you could somehow bring beta next to alpha, then you will have one angle alpha plus beta. So in general, that's a good tactic. When you want to find the sum of angles, you draw your auxiliary elements in such a way that the two angles come next to each other. In some problems, you might want to find the sum of line segments, in which case your auxiliary elements would be such that the line segments come together next to each other. So how can we do that here? So we will take this largest right angle triangle and transform it in such a way that these two angles come next to each other. So what we have done here is we have moved this triangle down and rotated it by a certain angle. So now you have alpha and beta next to each other. As it is, it's not very useful because we want to have some triangle in which alpha plus beta is one of the angles, preferably a right angle triangle, because most of the triangles in this equation are right angle triangles, right? So the way we can do that is we could drag this side towards the right such that this vertex coincides with this one, in which case you will get a right angle triangle in which alpha plus beta is one of the angles, right? So we have dragged this. Now for different problems you might want to drag it to different places. In this case, dragging it in such a way that these two vertices coincide makes most sense because you get a right angle triangle in which alpha plus beta is one of the angles. So more often than not, the most intuitive auxiliary element works, right? So try that first before trying to draw other kind of elements. So you have now a right angle triangle in which alpha plus beta is one of the angles, so that should help. Now when you look at this figure, you will see that there are three triangles which are similar to each other. You have ABF, in which one of the angles is beta. All three triangles are of course right angle triangles. ABF has beta as one of the angles. Now CDE is going to be similar to ABF because we got CDE only by transforming ABF, right? We moved it down, we rotated it, and then we scaled it down. So CDE is similar to ABF. What you also have is the triangle CAB, right? Angle DCE and BCA are the same, right? Vertically opposite angles. And angle ABC and CDE are both right angle triangles, and so the third angle must both be the same. Since this is beta, angle BAC should also be beta, right? So you have three triangles, ABF, CDE and CBA, which are all similar, with side ratios 1:3:10, root 10, because that's given in the equation, right? So if this is, it's given that this is A and this BF is 3A, and so the hypotenuse must be root 10A. Alright, so now we have pretty much everything that we need to compare the values of AD and D. So that's what we are trying to do, right? we want to get some idea as to what alpha plus beta is. We can do that if we get some idea as to how AD is related to DE in terms of its length. Excuse me. So in triangle ABC, we know the values of all the three sides because we know the ratios and we know the value of length of one side. However, in CDE, we don't know the lengths of any of the sides. So we'll assume that CD is T, in which case DE becomes 3T and CE becomes root 10T. Now, BE is 2A, right? It's given in the equation. So this whole length 2A is equal to A by 3 plus root 10T, because basically BE is BC plus CE and BC is A by 3 and CE is root 10T. And so from this equation you can get an expression for T in terms of A. So now you know the lengths of both AD and DE in terms of A. What you will see is AD is equal to DE, right? Since 3T is equal to T plus root 10 A by 3. You put in the value of T as 5A by 3 root 10 and you will see that these two sides are the same. So ADE is essentially a isosceles right angle triangle, and so alpha plus beta must be equal to pi by 4.